So today we are going to start our transaction topic because we want to finish the topic quickly. So then while we are doing the transaction, we will be doing the past paper questions and the query optimization. Okay, right. So because transaction is the biggest topic, once transaction is done, the bulk is done. Okay, so other topics are just small topics. Okay, and also we are planning to have another addition to this regular session on Friday evening. We'll be having another session, maybe big session about 5 hours session Friday because it's a holiday, right? So we'll try to finish as much as possible on that day. Okay, right. So let's do that. I shared the transaction note, right? I shared the transaction note. We'll today finish the transaction as much as possible. This is the most complicated topic other than the index part. Okay, right. Transaction management. So I'll be doing very fast because this is not as fussy as index topic. Only thing is you have to pay a lot of attention, and if you lose somewhere from that point onwards, you are going to lose everything. Okay, right. Right. So what is transaction? So transaction is a set of activities which must be success as a whole or fail as a whole. Okay. For example, if you are doing a money transfer from one account to the other account. So now first account, you must have a debit, other one credit. So either both are happen, or you can't say only debit is happen, but the credit fail. So then it is illegal. Right? Either both are happen or none happen. If the first when the first one is done, if you get an error in the second one, so you have to reverse the first one, or both are done. Okay. So we use a bit of terminology here. So we have starting of a transaction, ending of a transaction. So then individual activities are happening, and at the end we say we have commit the transaction. So that means everything is successful. But if at any point, if a particular action fail, then we have to roll back. Roll back means we have to undo all the previous actions also. Okay, so that is how the transaction happens. Transaction must be either commit or it must be rolled back. 100% success or 100% fail or reverse or something like nothing happened. Okay, right. Right, roll back, commit. So this transaction handling is very complicated because there are so many other aspects also connected to that. One thing is concurrency control. While you are working on a particular data set, there can be another transaction working on the same data set. So which make your transaction handling even more complicated, like even more complex, right? Maybe you are also doing a transaction on your account. So you try to withdraw money, and someone else is also trying to transfer money to your account, same record. So then there are some complications which we have to handle. That is called concurrency control. We don't mind two people go and withdraw money from their respective accounts. That is not concurrency. But if there are two transactions involved in the same record, that is concurrency handling. So those are really challenging. We need some locking mechanisms, etc. Okay. And the other thing is recovery management. While those transactions are happening, if the database crash due to hard disk failure or security or network errors, so how can we recover those? Because partial success will result in business logic wise illegal situation. Okay, so we must be able to recover from that point onwards using transaction logs and other things, and last backup and other things, right? So therefore this is fairly complex topic. Okay, fairly complex topic, right? Right. So when it comes to transactions, it's all about reading and writing, because we have to read data and we have to write data. Sometimes we read data, sometimes we have to write data, right? Whether it's insert to update, we consider it as a writing, right? But if I'm just retrieving, checking the balance or whatever, then it is only read operation. Okay. For example, if you take insert operation, so insert means you have to now look at the disk level. You have to get the disk block to the memory where you are supposed to insert the new record, then write that record to that disk block or memory page, and you have to write it back to the disk. So therefore, it's a read and write operation. Read it, write the value in the memory, and write that block back to the disk. Update is also like that. You take that block where your record is, do the update, and you have to write the block back. You can't just read a record. The minimum block size of data that you can access is the block. So your block will have sometimes hundreds of records, right? Maybe you are just interested in one record. Still, you have to get that block to the memory. You can't just take one record, okay? And delete is also like that. Say you want to delete a particular record, you have to get that block containing that record, delete that record in the memory, and write back the block without that record. Okay. So therefore, whether it's insert, update, or delete, it is read and write operation. Right? Read and write operation. But only when you are doing a select statement, then it is only a read operation because you don't write it. So select is only read. Insert, update, delete are read and write operation. So therefore, in transaction handling, we look at those things as set of read and write operations, right? Set of read and write operations, right? So I'm doing very fast. Therefore, if you have any questions, of course, you are supposed to have a lot of questions because I'm doing very fast. You have to ask then and there. Okay, don't wait until the syllabus is over and then ask. Okay, so this is the best time to ask because I have time to explain it also, right? Right. So ACID properties. So every transaction must comply with ACID properties. ACID properties means its acronym: atomic, consistence, isolation, durability. Okay. So atomic means, as we already mentioned, your transaction must be either success as a whole or fail as a whole. This is the unit. This is the atom. You can't subdivide and say this is success, this is fail. No. So atomic means it must be success as a whole or fail as a whole. Fail means undone. Consistency means if your database data is consistent business logic wise before particular transaction, at the end of the transaction also, your database data must be consistent with business rules, right? The third one is isolation. I told you that there are multiple transactions happening and sometimes these transactions may refer to the same records. So undesirable effect of one transaction must not expose to the other transaction. We are not saying that one transaction must not expose to the other transaction. Of course, they will be exposed, but only thing is undesirable effects must not be exposed, right? ඒකෙන් අනිත් එකට බලපෑමක් වෙනවා. Undesirable විදියට ඒව තමයි expose කරන්නේ නැත්තේ. එහෙම නැත්නම් එකම රෙකෝඩ් එක දෙකම වැඩ කරනවා. right? එහෙනම් වැඩ කරාට කමක් නැහැ conflict වෙන්නේ නැත්තම්. right? So that is a very interesting area that we are going to discuss. And finally, the durability or the permanency. So durability means once your transaction is committed, it must be permanent, right? Even when the power is off, it must be permanent. So then someone will say that is obvious thing, but there are so many complications due to buffering, caching, and other things. So we have to flush those things and other things that has to be happen. Otherwise, those records may not be reflected in the storage. Okay. Right. So when we are doing transaction handling, there are some possible issues. So we call them possible problems in concurrency handling. What are those possible issues? We can call them write-write issue, write-read issue, read-write issue, and phantom issue. Okay. So write-write, write-read, read-write, and phantom. So now here you can see only possibility is read-read. Right? Read-read is not an issue. That is not a possible issue. But these three other combinations are possible issues. And there's an additional issue called phantom issue. Okay. And we have given them some name also. This write issue is given the name lost update. Okay, we'll take one by one. So the first one is write issue. Remember, actual transaction may be doing insert, update, delete, but we are looking at everything as either write or read operation, or both read and write operation. Okay, so that is why these issues are related to write, etc. These issues may happen when you are doing insert, update, delete. Okay, right. First one is write issue or the lost update. So the write issue means, say, one transaction write a particular data, okay, as part of its transaction one task, and this other transaction, this is transaction one, has written to that particular data or data record. Transaction two also write it on top of the previous one. Now what will happen is, the value that transaction one has written is lost. It's lost. So that is called lost update issue. Okay, lost update issue. Right? So it's something like, now these things can happen in, especially when the elections are nearing. Okay, so you know that they have poster campaigns. So one candidate will paste posters on a poster post. Okay, or poster boards. Maybe they paste it 11 p.m. in the night. Then the other people come and override it maybe 2 a.m. in the morning. Now the first people's posters never visible to the general public, because their posters were overwritten by the other candidates' posters. Same thing, right? So now it's something like the previous write is useless because it is overwritten, right? So that is called write issue. Write issue. Okay. For example, there are two deposits happening. Earlier the balance was 1,000. So this guy is depositing say 10,000, and this guy is depositing 5,000. Now we read, both have read the value 1,000, and this guy increment it by 1,000 and write it as 11,000. This guy, when read, it was 10,000, now incremented by 5,000, and it's written as 15,000. But now reality, it should have been 16,000. But since both happens at the same time, both has read it, the original value, and by the time second guy write it, the first guy has already written, but both has read the 10,000. If it is at least 1 second later where this guy updated, then this guy read it 11,000 and add 5,000 and it says 16,000. But the issue is when they both read at the same time and both transactions happen at the same time. Okay, so that is where the lost update happen. Okay, right. So write issue. So the second issue is write read issue. Write read. Okay, it's very important to understand these things. You may feel like you have understood it, but in reality, you will not understand the concept. Okay, right. So therefore, you have to spend more time until you feel you are confident that yes, I have fully understood it. Right. So next one is write read issue, or the uncommitted dependency, or the temporary update, or dirty read issue. Right. So this one is the better word, the dirty read. Okay. So what is that? So that is first transaction write. Transaction one write to a particular value. Say it has changed it to X. Okay, X. Now transaction two read afterwards. Transaction two reads. Earlier say it was X. Transaction one make it Y. Now then you read it. Now you are read it as Y. So that is temporary update or dirty read, because this is a dirty value. Why we call this Y as a dirty value? Because transaction one has not committed yet. It has not committed yet, but as intermediary step, it has updated. Remember, transaction is set of activities. It has updated this to Y, but now while it is doing the other task, the other guy has already read it. Other guy has already read it. Now this guy has read it as Y. Okay. Originally it was X. But after this guy change it to Y, you have the second transaction ready. Now there's a possibility that because it's a set of actions, maybe one of the other action failed, and therefore transaction 1 has decided to roll back it. Roll back means this guy is rolling back Y back to X. But unfortunately, this guy has rolled back it to X, but this guy has read it as Y. Right? So transaction Y change it to Y and again roll back to X. While it was Y, transaction 2 read it. So transaction 2 still think that it is Y, not X. But in reality, it is not Y, it is X because the transaction 1 rolled back it. So that is write read issue. Okay, write read issue. Or temporary update or dirty read. Actually, this is a dirty read. Right? Dirty value का मैं किए right? Dirty value का कियो करते. So that is second possible issue. Write read or the dirty read issue. Okay. Right. So if you have any questions, you have to ask and clarify it because you may understand it differently than what I mean. So therefore, whenever you have doubt, you have to ask. Okay, these are not easy subjects, right? This is final year. Only 250, 300 odd students pass the degree, right? Out of thousands, okay? Right. So that is write read issue, right? Write read issue. Now you can see this guy has reduced X by N and written it, but still the transaction goes on. So while the ones it has reduced N from the X, the second guy has read it. Now it is reading the current value, that is X minus N, and it is adding M, and it has written. And this guy has rolled back. Now what you read as X is not the correct value. So that is why we say it's a dirty read. Okay, because if this guy does not roll back, that is okay. But who knows? There's always that possibility of rollback. So we have to think about that. We have to tackle that kind of possibilities. Okay, dirty read or write read, right? Write read issue. So the next issue is, right? So you have to go through these examples and understand it, okay, further. And if you have any doubt about these examples, you have to ask. You have to ask saying that, okay, I don't understand this example, okay? Immediately, not day before exams. Right. So the next conflict is read-write conflict. Now we have discussed write-write, lost update, write-read, dirty read. This is read-write. Read-write. Or sometimes we call it unrepeatable read or inconsistent summary or analysis problem, we call it. And special case of read-write is Phantom. Phantom we will take as a separate one. Okay, read-write conflicts. So what is read-write conflict? I told you that only read-read is not a possible conflict. So how can this be an issue? So this is what happened, a possible issue, okay? Right. So now this guy has read it. Transaction 2 has read it. Say X value is 80. Now transaction 1 has done some changes, writing. So now assume it is now no longer 80. It is now something like 75 because assume this guy has reduced it by 5. Now the transaction 2 is again reading, right? Again reading because the transaction is not over. Maybe now this transaction is involved in generating reports. So now the first report is done, generated. But at that time, X was 80. Maybe it was doing some other tasks in the same transaction. Now again, it is reading the same record for maybe for different report now. In between those two, the other transaction 1 has changed that value of X. Now for the first report, X was 80. For the second report, the value of X is taken as 75. Now that is what is mean by read write. After you read, someone has written. So therefore, when you read it again, or you can rather call it read write or read write read issue. Okay, read write read issue. Read write read. Now second time when you are reading, then it's not consistent. Same data in between two tasks in the same transaction, you see it as two different values. Two different values. So that result in inconsistency in your calculations, your reports, etc. So that is why we call it unrepeatable read. So when you repeat it, you get a different value. Inconsistent summary means if you are taking two reports, now the summary reports are inconsistent. Or when you are analyzing, your analysis is inconsistent. Because of this guy has changed it in between. Okay, so that is called read write conflict. Right? So write write, lost update, write read, dirty read, and read write or unrepeatable read or the inconsistent summary or the inconsistent analysis. Okay. And there's a special case of read write conflict called phantom phenomena. So phantom, we can take it as a different aspect as well. Okay. So phantom phenomena, what happens is, okay, say you have read it, you have read the value. Say you have read you are doing a summation, some calculation. You have read all the employees' information data to do a calculation for the first report 1. Now you are doing other tasks and you are coming back to do the second report. In between, someone has inserted a record to the same table. Say you are doing a report, generating a report about the employees. Now the first report is done. At that time, there were 3 reports. Now you are doing the generating the second report. By that time, there are some more records inserted into the table. So that is a special case of read write. It's also read write or read write read. Okay, but this time it is not changing the data, rather inserting a deck record, or sometimes it can be even delete a record. Right? These kind of things can affect only when you are doing sort of a big reports, overall reports, because phantom is not going to affect another record because it's not update. But if you are taking some reports, overall reports, yes, it can also result in some inconsistencies. So therefore, it's a special case of read write, right? Special case of read write, the phantom phenomena. Okay, so now you must know the what are the possible issues: write write or lost update, read write, sorry, write read or dirty read. This happens when the first transaction roll back. Read write, that is unrepeatable read or analysis issue. Okay. And the special case of this one called phantom issue. Okay. Any questions? Because 100% තේරුම් ගන්න පුළුවන් සබ්ජෙක්ට් එකක්. 100%. 99 නෙමෙයි. 100% තේරුම් ගන්න පුළුවන් සබ්ජෙක්ට් එකක්. හැබැයි effort එකක් දාලා. Okay. So therefore, if you don't understand a single point, you have to then and there ask. Right. තේරුණා නම් අපි ඊළඟ level එකට යනවා. ඊළඟ topic එකට. Right? Okay. Concurrency control levels or isolation levels. So when it comes to transaction handling, there are different levels of controls we can have. I told you that transaction handling is a very complicated task. We have to think about the recoveries in case of failure. We have to think about the concurrency issues while you look at all those things. Okay. At the same time, we have to make sure that our database is high performing. Okay. Right. So therefore, it's a trade-off. It's a trade-off. If you want to do a lot of restrictions to have a lot of consistency, it is going to delay your transactions because we are going to prevent some concurrency. Okay. At the same time, if you try to make it very efficient, sometimes it may result in inconsistencies and other issues. So therefore, it's a trade-off situation. So therefore, you can set up when you in your database which level you are going to operate. Are you going for very good consistency, of course, with compromising the performance, or you are more interested in performance, where here and there can be some inconsistencies. Okay. Right. So therefore, we have levels. So what are the 4 levels? Read uncommitted level isolation. We call them isolation levels. Read committed level isolation, repeatable read isolation, and serializable level isolation. So this is the best. Serializable is the best approach. The best in the sense it prevents all the possible evils. But that is where you have the biggest performance hit as well. So read uncommitted level is the least guards, but best performance. So here all the guards are there working, but the performance is lesser. But most of the time databases go for the level 4 because more than performance, we are interested in the consistency or the acid properties. Okay, because especially if it is something like bank or something, we don't want to take risks. Okay. Right. So these are the 4 levels. Now in the database system, when you are starting a transaction, you have to set these isolation levels first. Usually by default, it is serializable. Okay, databases by default take it as serializable. Right. So if it is serializable, these 4 issues, all 4 issues are prevented. Dirty reads, lost update. Now you must familiar with these words because I mentioned those things. Non-repeatable reads and phantom. All 4 issues are prevented. If you go to the repeatable read level, then phantom may occur, but other 3 are guard against. If you go for read committed isolation level, dirty read will not happen, but other 3 can happen. That is lost update, non-repeatable read, and phantom can happen. If it is read uncommitted, all 4 issues may happen. So that is the weakest level. Right? Weakest level. You don't have much of a control or against those possible evils. Okay, possible issues. Okay. So usually databases go for serializable, but you must know the 4 levels because in the exam they have asked these things, and you must know in which level which things are guarded, which things are still open. Okay. So when you are doing transactions, remember the database. There are different type of SQL: data definition language, that is create, alter, drop. Then you have data manipulation language, insert, update, delete. Okay. Then you have data query language, that is where you have select. Then you have data control language, which all 4 you learn in your semester 2 database subject. Semester 1 then 2 ne. So we have covered all 4 in your database 1. Right? These and these. These are the invoke, grant, security. So the 5th aspect of SQL is transaction control language, TCL. Okay. So these 4 you have done in your level 1: DDL, DML, DQL, and DCL. And this is what we are going to learn here: transaction control language. So that is all about how the transactions are handled. Okay, so usually when you are starting a transaction, I told you default is serializable. If you want, you can set it specifically to serializable, because if you have changed it to other level, again you have to set it to serializable. So this is how you set the set transaction isolation level, read uncommitted, read committed, repeatable read, serializable, etc. Okay. I don't know whether MySQL has a different syntax, because transaction handling I have not tried out in MySQL. Let's see. Maybe slightly different syntax, because this is databases. Sometimes databases use little bit of different symbols. Say MySQL minus u root. Show databases. I'm just connect to one of the database. Okay, let's say use S2B1. Command set transaction isolation level. exam එකේ වල standard SQL විතරයි අහන්නේ MySQL එහෙම අහන්නේ නැහැ SQL වැඩි අහන්නේ නැහැ අතන theory බලන්නේ ඒගොල්ලෝ say serializable very okay, so that we have set it to the serializable level. Okay, I think the by default is also serializable, right? So likewise you can change the isolation level. So serializable is the highest level, the strongest level. Okay, strongest level. Then you have to begin your transaction. සාමාන්‍ය transaction මේ SQL ඊට පස්සේ ලියන්න පුළුවන්. හරි. say අපිට ඕන කියමු අපි උදාහරණයක් විදිහට say show tables this body table එකක් ගන්න. select all from employee department. Say I want to do insert. Okay, I don't want to let's do an update. Okay, update update. හරි ඉතින් transaction එක පටන් ගන්නවා මම. හරි මම හිතනවා මේක MySQL වල වැඩ කරයි කියලා. වැඩ කරන්නේ නැත්නම් බලන්න වෙනවා. හරි begin transaction BEGIN transaction say MySQL start transaction. සමහරට පොඩි commands වෙනස් වෙනවා. හරි database එක මත start transaction ඉස්සෙල්ලා මේ auto commit අපි off කරලා ඉන්න ඕන නැත්නම් auto commit වෙනවා. හරි say set auto commit off නැත්නම් auto commit වෙනවා. SQL එක ගහුවම අර පැත්තට මෙයා වැඩ කරා යා. So now let's say start transaction. Transaction has start kala din denga. Right, now let's do update department set name equal, okay, set location equal, let's say Vaunia. I don't know how to spell. Where department ID equal 4. So query okay, one row affected. Right? Okay, then අපි අතනින් ගිහලා බලමු මේ change එක පේනවද කියලා. හරිනම් පේන්න බෑ හැබැයි ආ. තාම commit කරේ නැහැ. So php my admin, okay? php my admin localhost sem1 batch 1 එකේ තේනවා තාම ජැෆ්නා SQL එක commit SQL එක ගහලා තියෙන්නේ ආ SQL එක ගෙවට තාම තියෙනවද ජැෆ්නා because we have not I have set it to දැන් සාමාන්‍යයෙන් එහෙම කරා නම් ඔතන ආවිල refresh කරලා දෙනවා හරි so now at any time I can roll back also at any time I can roll back because this change is only visible to this particular transaction මේ update එක තාම පේන්නේ මේ transaction එකට විතරයි හරි right now we can do some other activities as well say I want to update something else blah 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 okay so then you have to either commit or roll back okay so begin then only you have to say in transaction so let's commit 10 because I have set the auto commit off okay now I'm going to say commit now I can say end transaction make පටන් ගන්න start transaction කියන්නේ ඔව් begin transaction නේ මෙයා කියන්නේ start කියලා හරි MySQL ගේ end transaction end නෙමෙයි එන මොකක්ද වෙන වචනයක් ඇත්තට MySQL එක start හරි end කියලා එකක් වෙනම නැහැ commit වලින් end වෙනවා හරි commit කරා කියන්නේ end හරි දැන් බලමු මෙතන දැන් commit කරානේ දැන් බලමු මෙතන ඇවිල්ලාද කියලා දැන් commit ඉස්සර commit කරලා නැතුව බැලුවම ජැෆ් නැති වුනේ let's refresh now it's found here now you can see that once I commit only other sessions can see it දැන් මොන transaction එක end කරා හරි මම අර auto commit එක ආයෙ on කරනවා දැන් බලමු අපි update එකක් කරලා so let's change it to Ampara now it is not in a transaction and also I have auto commit on right? Now immediately it must be available here then we can refresh කරගම පේනවා commit කරන්න දෙයක් නැහැ now you can say Ampara right so there is a difference between transaction because transactions until you commit right others will not see it when I say others will not see it others will not see the undesirable effect සමහර දේවල් පේනවා හැබැයි ඒක දැන් කතා කරන්න හදන්නේ right so and also we can roll back මෙතන commit කරන්න නැතුව roll back කියලා ලිව්වනම් එතකොට transaction එක අර මම වවුනියා කරපු එක ආයිමත් මේ ජැෆ්නා වලට roll back වෙනවා හරි right so I hope you have some idea about what is this transaction handling okay committing rollback etc right so and also how to set the isolation level okay isolation level so by default it is anyway serializable you can set it to other things so this actual command can be slightly different from the database. Okay, whether if you are using Oracle or Microsoft SQL or MySQL, so slightly different, but you don't have to worry, right? For the exam, they don't check your SQL knowledge. What they check is the concepts. Okay, right. So now we are any questions on that? Any question? Because this is serious stuff we are talking, serious stuff. And the passing rate is very low when it comes to database subject, very, very low. Right. So now we are going to discuss about transaction schedules. Okay. Transaction schedules. Right. So transaction schedule means your DBMS will, now remember, it's not one transaction. There are multiple transactions are happening. Transaction 2, transaction 3, transaction 4. Think about something like a global bank. How many transactions will be there at a particular time? Right? Think about it. Think about something like MasterCard, Visa, because they have to authorize, they have to track each and every credit card transaction in the world. Right? So hundreds and thousands of, sometimes 10,000, right? Transactions are waiting for in the queue to do it, to do their activities. So therefore, what happened is your DBMS create a schedule. Right? On the fly. Make me head අදවස වෙනවා අද schedule කරනවා නෙමෙයි. මේ දැන් transaction ඇවිල්ලා ඉන්නවා queue එකේ. Queue එකට එනකොට ඒවා ටක් 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 ගාලා schedule එකකට දාලා execute කරනවා. Execute කරනවා. මේක this is a real time activity. This is a real time activity. And they real time create this schedule. මේ හරිය schedule එක හදනකොට මේ හරිය schedule එක execute වෙනවා. හරි database එකේ. So that is what happens. And the DBMS use special logic, special tactics, strategies to make that schedule non-conflicting. So it makes sure that the schedule is efficient. At the same time, none of your transactions will violate the ACID properties. Right? None of the transactions will violate the ACID properties as well. As well, at the same time, they want to make it very efficient as well. Otherwise, transaction queue is going to be very lengthy. Hari wada ude 9ට ගහන transaction එකක් 10 මාට තමයි එහෙම නැත්නම් ඉතින් වැඩේ ඉවර වෙන්නේ. ඇත්තටම ඉස්සර එහෙම තමයි. හරි පැය ගණන් යන්නේ නැහැ. ඉස්සර සමහරට බැංකුවේ transaction එකක් කරන්න ගියාම. ඔය credit card transaction කරන්න ගියාම සමහරලාට මේ කැරකේ තියෙනවා. විනාඩි 3කින් විතර ඔන්න සක්සස් කියලා එනවා. ඉස්සර මේ ඉන්ටර්නෙට් උත් ස්ලෝ අනිත් පැත්තෙන් රිලයබිලිටි ප්‍රශ්නක් තියෙනවා. ඉතින් දැන් හරි ඉස්සර ඒක ඔන්ලයින් මනි ට්‍රාන්ස්ෆර් කරන්නේ අපි හරි අකමැති. මොකද මේක අන්තිමට කොහේ මොනවා වුණාද දන්නේ නැහැ. සමහරට කැරක දිවිලා ඔය කැරකේරීම තියෙනවා. අන්තිමට මේක සක්සස් දන්නෙත් නැහැ, ෆේල්ඩ් දන්නෙත් නැහැ. අර ඩේටාබේස් වල ට්‍රාන්සැක්ෂන් ඉන්නවා queue වල. Right? But these days, that is not the case, right? You know that when you are doing a money transfer or something like that, within 10 seconds, 15 seconds, the transaction is over, right? Because the databases use very sophisticated mechanisms to do those transactions in a way parallelly, without any undesirable effect or without violating ACID properties also. Therefore, this is very interesting task. Right? So how to create those transaction schedules, mixing these transactions and allowing them to proceed as much as possible. Okay, right. So what is a schedule? සමහරවල් කෙලින්ම හදන schedule එකක් කියන්නේ මොකක්ද කියලා. Right. Schedule is set of activities arranged in a time ordered manner. Schedule like set of activities arranged in a time ordered manner. Now you know that there are schedules for a meeting. There are schedules for a television programs, right? Schedule. So 8 the news, 8:30 there's a teledrama, right? It's a set of activities or tasks or whatever but arranged in time ordered manner. Then we call it schedule. Okay. So then what is transaction schedule? Transaction schedule is set of actions of transactions arranged in time ordered manner. Transaction 1, transaction 2, transaction 3, right? Transaction 4. So there, each transaction has set of activities. Right? Each transaction has set of activities. This transaction has to select some data from one table, then update this table, insert to that table, then again update this table. This one also has that. So how these things can be arranged? So that is transaction schedule. Okay, transaction schedule. So when the transaction schedule is created, it's on the fly. හරි මේක මම කිව්වේ කලින් මේ අපි දන්නේ වෙන දේවල් මේක වෙලේ රියල් ටයිම් එකේ තමයි ෂෙඩියුල් එක හදන්නේ මේන් හදනකොට අනිත් එක එක්සිකියුට් වෙනවා තප්පර මිලිසෙකන්ඩ් ගානකට කලින් හදපු ට්‍රාන්සැක්ෂන් ෂෙඩියුල් එකේ හරිය එක්සිකියුට් වෙනවා ඒ එක්සිකියුට් වෙනකොට මෙහෙන් හැදෙනවා ෂෙඩියුල් එක ඕකේ එහෙමයි වෙන්නේ okay so it has to be optimum performance wise otherwise your database is going to be very slow ඔයගොල්ලෝ දැකලා තියෙන සමහර තැන් වල එන්න පොලිම දික් කරලා අන්තිමට පොලිම හිර දිගයි. අර ගෑස් පෝලිං එහෙම තියෙන්නේ නේද? කිරිපිටි පෝලිං තියෙනවා මොකද එළියට එන්නේ පොඩ්ඩයි. ඉතින් පොලිම දික් වෙනවා අන්තිමට. පොලිම දික් වුණාම උදේ ආව මනුස්සයා හවසට තමයි ගෙදර යන්නේ. එහෙම වෙන්න පුළුවන් බැංක් එකක් වගේ තැනක transactions ටිකක්. So therefore the schedule has to be optimum. Right? So it must preserve the acid properties and at the same time make sure it's efficient. Okay, make sure it's efficient. Right. So when it comes to creating transaction schedules, which is done by your DBMS. Okay. So there are two types of schedules: the serial schedules and serializable schedule. Okay. So those are the valid schedules. If a transaction schedule is valid, business logic wise, or if it is not violating the acid properties of any of the transaction, then we say it's a valid schedule. If it violates the acid properties, so at least it has the potential of violating that acid properties, then we say it's an invalid transaction schedule. Your DBMS always make sure that it keep generating valid transaction schedules. Okay, valid for each and every transaction. So these valid transaction schedules can be of two types: the serial schedules and serializable schedule. Okay. So serial schedule means the schedule is actually serial. One transaction is completed, then go to the second transaction, maybe transaction 4, transaction 6, maybe then transaction 3. It doesn't matter whether it is there is no rule saying T1, T2, T3, T4. No. Maybe T1, T2, T4, T6. All are valid. All are valid. If it is a serial, it is always a valid transaction schedule. Serial schedules are always valid. Why? Because there are no risks. We do one transaction, finish it, and go to the next transaction. There is no concurrency. There is no concurrency. No two transactions happens at the same time. Right? No two transactions happens at the same time. So therefore, it is always a valid transaction. Right? Schedule. And again, it doesn't matter whether after T1 after T2 or T2 after T1. ඒක අපිට වැදගත් නැහැ. අපිට වැදගත් නැහැ. අපි උදේ පාන්දර යනකොට බැංකුවේ ඉස්සරහා ඉන්න කස්ටමර්ස් 10 දෙනෙක් ඇවිල්ලා. හරි. ඒගොල්ලෝ පොලිම් එකක් නෙමෙයි ඉන්නේ. දැන් බැංකුවට වැදගත් මේ 10 දෙනාගෙන් ඉස්සෙල්ලා ඉන්න ඕන කවුද කියන එක. බැංකුව කියා we don't care. අන්තිමට ආපු එක්කන ඉස්සෙල්ලා බැංකුවට ආවත් අපිට ප්‍රශ්නයක් නැහැ. From bank's point of view, it doesn't matter which transaction happens first. Of course, it may matter for them, the customers, but it is not a matter for the business. So therefore, we don't care whether it is T1 after T2 or T2 after T1 or whatever. As long as it is serial, it is always valid. It is always valid. Serial schedules are always valid. Okay. And also, if there are two transactions, there are two possibilities, T1, T2, and T2, T1. Two transactions, two possibilities. Three transactions, T1, T2, T3. And it was a T1, T3, T2. T2, T1, T3. Kiyat තියෙනවද එහෙම? ඔයගොල්ලෝ කියන්න කීයක් possibilities තියෙනවද කියලා? ඔය අහලා තියෙන exam එකේ. Kiyat තියෙනවද? Anyone? So there are three transactions. How many serial transactions are possible? T1, T2, T3, T1, T3, T2, it was a T2, T1, T3, T2, T3, T1, and finally T3, T1, T2, and T3, T2, T1. Six possibilities are there. හතරක් නම් කීයද? ඒවට තමයි maths කරේ. semester 2 counting කියලා subject එකක් කරා නේද? එකිනෙක වෙනස් හතර දෙනෙක්ව arrange කරන්න පුළුවන් විදි කීයක් තියෙනවද? So there we have four transactions. We are going to arrange them linearly. How many ways are there? Factorial 4. 4 into 3 into 2. 24 ways. If we have n transactions, there are factorial n number of serial schedules, valid serial schedules, because every combination is valid for the business. Every combination is valid. Okay. So those are serial schedules. So serial schedules are very simple. Very simple. Logic is very simple. But unfortunately, serial schedules are the least performing, the slowest. ඒවා තමයි ස්ලෝම. මොකද එක්කෙනෙක් ඉවරනව තමයි අනිත් එක්කෙනා කරන්නේ. පැරලල් වැඩ කරන්නේ නැහැ. එක්කෙනෙක් පොඩි අපි හිතමු එක ට්‍රාන්සැක්ෂන් එක ඩිලේ එකක් තියෙනවා. තමයි ඔයගොල්ලෝ දැකලා ඇති. හඳනේ මම නම් ඔක දැකලා තියෙනවා. රජයේ බැංකුව වලටයි ප්‍රයිවට් බැංකුව වලටයි ගියාම දැන් නම් බැංකුව වලට පියනවා අඩුයිනේ. ඔන්ලයින් 199ක් වැඩ කරගන්නේ. සමහර රජයේ බැංකුව වලට ගියාම දැන් අර පොලිමේ ඒ එක්කෙනාගේ වැඩක් ඉර වෙලා. ඒක දැන් මැනේජර් හරි කාට හරි ගිහිල්ලා මොනවා හරි අප්‍රූවල් එකක් අරන් එන්න ඕන. ඉතින් ඔක්කොම බලාගෙන ඉන්න පොලිමේ. ඒ සීරියල්නේ. රජයේ සේවක බහුතරය සීරියල්නේ කොහොමද? කැරකිලා ඒක ඉවර වෙලා අප්‍රූව් කරගෙන එනකන් අනිත් කට්ටිය බලන් ඉන්න. මොකද ඒගොල්ලෝ එකපාර එකයි කරන්නේ. ඒගොල්ලෝ සිංගල් ටාස්කින් කට්ටියන්නේ. ඔයගොල්ලෝ දන්නනේ යුනිවර්සිටි එකේ වැඩක් කරගන්න කොච්චර මාරුද කියලා නේද? Right. So that is the issue in serial schedules. And serial ඒ වෙලාවේ වෙන එක්කෙනෙක්ගේ වැඩක් කරගන්න පුළුවන් නේද? අර ටාස්ක් එකේ චුට්ටක් කළා ඒක ඩිලේ වෙනවා නම් ඒ වෙලාවේ අනිත් ටාස්ක් එකේ වැඩ කලවම් වෙන්න දෙන්නේ නැහැ. කලවම් වෙන්න දුන්නොත් අන්න it is a non-serial schedule. It is a non-serial schedule. Usually these non-serial schedules are more efficient than serial schedules. Because when we do some task in the transaction 2, while the transaction 1 task is some halted or whatever, so then we can make it even much more efficient. Okay, but the idea is we can mix those things. We do this and this and this and maybe this and this and then this. Likewise, you mix it. But when you are mixing, we can't just randomly mix it. Right? We can't randomly mix it. So that is where we have another concept called serializable schedule. So serializable schedule means we are going to mix those transactions together to create the schedule, but that schedule is equivalent to a serial schedule. One of the serial schedule, one of the factorial and serial schedules. Equivalent, result equivalent. Then only that schedule is valid. Right? So all the possible serial schedules are valid. All the possible serializable schedules are also valid. What is meant by serializable schedule? We are mixing it, But though we mix it, its result is equivalent to one of the serial schedule. So then those schedules are also valid. Those schedules are also valid. But if it is not equivalent to a serial schedule, those schedules are not valid transaction schedules. Acid properties violate when good. But acid property is not going to violate it by serial schedules and serializable schedule. Okay. Now these are the serial schedules. You can see 3 transactions, 8 possibilities. They are always safe. Right? They are always safe. So serializable schedule means it's a mixing. We are doing some mixing. It's not serial, but it's result equivalent to one of the possible serial schedule. One of the possible serial schedule. Result is equivalent. Of course, it is not a serial schedule. Make it in a result a serial schedule like a result equivalent. And these schedules are definitely more efficient than serial schedules because we are mixing. But these schedules, making these schedules are complicated. Yes, making these schedules because we have to make those schedules on the fly, real time. Make me other schedule like other execute කරනවානේ මේ. මේ එක එකනාගේ transactions මේ ඉන්නේ දැන්. මේක ටකස් ගාලා එවෙලේ හදන්න ඕන on the එවෙලේ හදනවා හදන ටික execute වෙනවා. Okay? Right. So how do you create serializable schedules? Or how do you know whether now we have 2 challenges. We have 2 challenges. Number 1, how to make serializable schedule because making serial schedule is a simple task නේද එක transaction එක ඉවර කරගන්න අනිත් ඒවා තියන් ඉන්නවා ඒක ඉවරනම තව එක්කෙනෙක් ගන්නවා හරි අර ડોක්ටර්ස් ලා ලෙඩ බලන්නේ නේද ඒකට ඒ ලෙඩා එළියට ගියාම ඊළඟ ලෙඩාව ගන්නවා ඒ ලෙඩාට බෙහෙත් කළ ඉවරනම ඊළඟ ලෙඩාව ගන්නවා so that is serial but serializable means we mix it, but it's equivalent to a serial schedule, right? So therefore, this is more efficient, right? So we have 2 challenges. Challenge number 1 is how to make serializable schedules. How to make serializable schedules. So that is a real challenge that databases has to do. Number 2 is check whether the given schedule is serializable. Is given schedule, that means transaction schedule, is given schedule serializable. කියන්නේ ආ serial schedule එකට equivalent කියලා check කරන්න. schedule එක හදුවට පස්සේ. So first we are going to discuss this. When you are given a schedule, check whether it is serializable, which is the easier task. Then we are going to discuss this. That is how to make serializable schedule. Okay. Right. So let's do the first one. I think one of you have not muted your microphone. So if you want to ask any questions, yes, unmute and ask. Okay, but make sure you mute it again. Right. So any questions up to this point? Anyone? I don't know whether you try to ask question. No? Right. So we are going to do the first one. How to check whether a given schedule is serializable or not. In other words, given schedule is equivalent to a serial schedule or not. Okay. So there are 2 types of serializable schedules. The BIT-UCSC schedules and conflict serializable schedules. Okay. BIT-UCSC and conflict serializable. Of course, the serial schedules are there. Those are valid. Then we have conflict serializable schedules. Those are also valid. But there are some schedules which are not conflict serializable, still they are valid, or still they are serializable, and we call them view serializable schedules. If it is not a view serializable schedule, it is non-serializable schedule. Non-serializable schedules වලින් අපිට acid property violate වෙන්න chance එකක් තියෙනවා. But all are schedules. Schedules අපිට බෙදන්න පුළුවන් කොහොමද? Non-serializable schedules, serializable schedules. All the serializable schedules are view serializable. And some of those view serializable schedules are conflict serializable. Okay. Some of those view serializable schedules are conflict serializable. And if it is serializable, it's always serial as well. Sorry, not always serial. The serial schedules are also there. Okay. Right. So first we are going to check. Now you know how to check whether schedule is serial. Right? Schedule is serial. ඒකේ තියෙන actions ටික මෙහෙම block කරාට පස්සේ පාට මේක අවුවෙනවා නම් T3, T2, T1, T4 කියලා. This is serial schedule. මේ තියෙන T3 වල task, T2 වල task, T1 වල task, T4 වල task. එහෙනම් ඉතින් serial. ඒක හොයාගන්න එක මහ වැඩක් නෙමෙයිනේ. Serial schedule එකක්ද කියලා. right. දැන් අපි බලන්න මෙහෙමනේ කලවම් වෙලා තියෙන්නේ. මෙතන තියෙන එකට පස්සේ මෙතන තියෙන එක, මෙතන තියෙන එකට පස්සේ මෙතන එක, ඊට පස්සේ මෙතන එක කොහොමම කලවම් වෙච්ච එකක් අපිට දීලා මේක දැන් T1 T2 කියලා පේන්නේ නැහැ. හැබැයි දැන් අපි බලන්න ඕනේ මේක serializable ද. එහෙන් බලන්න ලේසි විදිය තමයි. හැබැයි ඒකට ඔක්කොම අහුවෙන්නේ නැහැ. සමහරක් විතරයි අහුවෙන්නේ. conflict serializable ද කියලා බලන එක. We double check whether given schedule is conflict equivalent to a serial schedule. Okay, conflict equivalent to a serial schedule. So then we say it's a conflict serializable schedule. ඒක හොයන්න ලේසි. ඒක හොයන්න ලේසි. Serial schedule එකක්ද බලනවා වගේ හැඩ පෙන්නේ නැහැ එකපාරට. Now there's a technique to do it. Right. So we'll take a break. After the break, we'll discuss how to check whether a schedule is conflict serializable and how to check whether the schedule is view serializable. Okay. Now, okay. So we'll continue. Right. Now let's see how to check whether a particular schedule is conflict serializable. Okay. Conflict serializable means it is equivalent to one of the serial schedule. Okay. One of the serial schedule, and then it is valid. Okay. Right. Right. So how to check whether a particular schedule is conflict serializable? So these are the points we have to consider. So there's something called possible or potentially conflict. Potentially conflict. It doesn't mean that always conflict. So these potential conflict tasks or actions are, if it is a potentially conflict, it must satisfy these three conditions. What are those three? Right? Possible conflict dependencies. Okay. So what are those? Number one, the actions belong to different transactions. So we have two transactions, set of actions here, set of actions here. Actions within a transactions are never conflicting. Right? So therefore, if you have two actions, sub-actions, if they are in the same transaction, they are not going to potentially conflict. But if they are from different transactions, say this one and this one, so we are not saying that they are always conflict, but that potential of conflict is there, but no potential conflict here, these two or these two, but potential conflict is there here. So we are looking for first, what are the potential conflict operations? Okay. So then we will check whether actually they are conflicting. Right. So that is number one. So if they are potentially conflict, they must belong to different transactions. Second one, they must operate on that action must work on the same record, same data. Say this one is doing something on record 1. This one is, though they are in different transaction, it is working on, it is doing some changes to record 2. Then it is not issue. Though they are in different transactions, they are working on 2 different records. It's something like so there are 2 ATM machines. You also go there, I also go there. I am going to the other ATM machine and we are going to withdraw some money at the same second. But as long as you are withdrawing from your account and I am withdrawing from my account, there is no conflict. Right? Because they are 2 different accounts. So therefore, though they are in different transactions, if they are working on different data, still no conflict. Okay, still no conflict. The third one is, if they are working on the same data, 2 different transactions, same data, still one of the action must be right. If both are reading, 2 transactions, same data, both are reading, still no issue. But at least one is writing. So read, write, write, read, write, write. Those are possible conflicts. Possible. We are not saying that always conflicting, but that possibility is there. So what are the 3 things? They must belong to different transactions. They must work on the same record. And one of the action must be write action. So read, read is not a conflicting. Okay. So write, 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 read, write are possible conflicts if they belong to 2 different transactions. But read, read is not a possible conflict. Okay. Right. So now there's a technique to check whether, say, we have a schedule, transaction schedule, which has mixed different actions of different transactions. We can draw a precedence graph, right? Precedence graph, and check whether it is conflict serializable or not. Right? It's very easy, very, very easy. Okay, right. So let's do an example. Now this is transaction schedule. This is a transaction schedule and this is not a serial schedule. Why? Some actions of the transaction, say transaction 1 and 2, some actions of the transaction 1 is happening, then transaction 2 activities are happening, then again the rest of the transaction 1 is happening. So therefore, definitely it is not serial. Serial means after T1, T2. This is bit of T1, T2, bit of T2, the rest of the T1. So this is not a serial schedule. But we want to check whether this is equivalent to a serial schedule or result equivalent to a serial schedule. Equivalent can equal නෙමෙයි යා. Equal දැන් මේක serial schedule එකට equal නෑ නේ මේක serial නෙමෙයිනේ. Equivalent කියන්නේ ඔයගොල්ලෝ මේ O level වල කරනවානේ මේ බල නිව්ටන් 5යි. නිව්ටන් 3යි. අපි කියන මේ දෙක equivalent වෙනවා. මේ බල දෙක equivalent. ඒකට පාවිච්චි කරන වචනේ මොකද්ද? Equivalent කියන එක. හරි 5යි 3යි. මෙන්න මේ සමාන්තර ආශ්‍රයේ දිග සමාන බලයකට සහ ඩිරෙක්ෂන් එක මේකට equivalent. මේ බල දෙක දානවා කියන්නේ මේ බලය දානවා කියන එක නෙමෙයි. හැබැයි මේ බල දෙක දැම්මම ඒකේ result එක equivalent වෙනවා මෙච්චරක් දිග 5යි 3යි අපි 8යි නම් 8ක නිව්ටන් මේ ඩිරෙක්ෂන් එකට දාන බලය. Equivalent, right? So if this transaction is equivalent to one of the serial transaction, then it is serializable. It's serializable. Now, first thing we want to do is we want to write this transaction as set of read and write operations. Right? Set of read and write operations. So this is a read of x. අපි balance x කියන එක x කියලා ගමුකෝ. හරි. මෙතන x සහ y කියලා variable දෙකක් balance දෙකක් එක්ක වැඩ කරනවා. balance දෙකක් කියන්නේ account දෙකක balance එක වැඩ කරනවා. හරි. So this guy read x. Then he write the x. මොකද x කියලා කියන්නේ balance x. හරි. මේක calculation එක කියලා write කරනවා. Now the other transaction. It read x. Then it does some calculation and write x. Then it read y. Do some calculation and write y. And it commits. And commit කරපුවා දාන්න පෙන්නන්න ඕන. Now you can see it commits. Then the transaction 9 is again reading y and writing y. Now it commits. Now it commits. මේ වගේ එකක් දුන්නොත් ඔයාලට මෙහෙම අද ගන්න පුළුවන් වෙන්න ඕන. මේක මෙහෙම කරගන්න ඕන. මොකද මෙහෙම කරාට පස්සේ වැඩි ලේසි. Any questions on that? So we look at it as read and write operations. Okay. So we are not interested in these calculations. We are interested in read and write operations. Now we want to see whether this is result equivalent to a serial transaction. If it is result equivalent to a serial transaction, it is complete serializable. Right. Now we are going to draw the precedence graph. On the precedence graph, now we have T9, transaction 9 and transaction 10. Now we have to check whether what are the potential conflict situations. That means situations where these three conditions are satisfied. Dependency mark කරනවා. Right. So this is read and write. Anyway, same transaction, there is no potential conflict. So therefore, these two are not potential conflict because they are in the same transaction. What about read x and read x? No, both are read. Then write x and read x. There's a potential conflict. Two different transactions, same data. One of the operation needs a write. So therefore, there's a dependency from T9 to T10. T9 T10 T9 to T10 dependency is there because this write and this read. Not this read and this read, not this read and this write, but this write and this read. Then about another one, write and write. But anyway, we have already mentioned that. එකපාරක් mention කරා නැති. Write එකක් තියෙනවා. Then this is a new variable. අලුත් variable එකක් නම් මේවත් එක්ක conflict වෙන්න බෑ. Same data වෙන්න බෑ. So therefore, this is no issue now. These two are also no conflict. Why? Though they are the same data, it is within the same transaction. No conflict. Now we have conflict. You can see write y, read y. One of the operation is write. They are from two different transactions and the same data. So that is T10 to T9. Again, this is write to write. Anyway, we have readme. This is not a. This is not because this is the same transaction. So now you can see that there's a dependency from T9 to T10. There's a dependency from T10 to T9. Now you have a cycle. Now you can see this is something like a cycle. Right? So this is something like a cycle. So if there are cycles, that means your schedule is not conflict serializable. When you draw the dependency graph, if you have cycles, it is not conflict serializable. That is the concept. Okay, cycles exist and therefore not conflict serializable. Right? Okay, let's do another example. So this is our transaction. Transaction 1, this is the schedule. Make a schedule එක මෙහෙම read කරන්න ඕන. හරි මේ පැත්තට. schedule එක දිහා අනිත් පැත්තට. So this is how the time goes by. This one, this one, this one, this one, this one, this one. Okay. Right. So this is transaction 1, transaction 2, transaction 3. X, Y, no issue. X, Y, no issue. This is no issue. Same transaction. Now read, write on nekakahuna. Right? Read, write, two transactions. T1 to T2, there's a dependency. Then this is X, this is Y. Then read color, then write color, another one. That is T2 to T3. මෙයාගේ මුකුත් නැහැ. මෙයා x නේ. දැන් මෙතන ඉන්නේ. ඊට පස්සේ මෙයා y මෙයා x අවුලක් නැහැ. මෙයයි මෙයා අතර අවුලක් නැහැ. මෙයා x write සහ read මොන තව dependency එකක්. Write to read two transactions same data, one of the action is write. That is T2 to T1. Now you can see there are cycles. Mention cycle here. Maybe we'll calculate. So therefore this is not conflict serializable. Graph is cycle, therefore it is not conflict serializable. This is the cycle. ඒකත් හරි කියන්නේ. මේ විදිහට schedule එකක් හදුවට මේක conflict serializable නෑ. Serial schedule එකට equivalent නෑ. Let's take another one. මම කීයද තේරෙන්නේ නැත්නම් කියන්න. ඉතින් පොඩි example එකක් බලමු. Rest of the day. Let's do a past paper question and come back. Okay. Right. Consider the following schedule created using transactions. Is this schedule conflict serializable? Give reasons. If the above schedule is serializable, determine an equivalent serial schedule. So then අපිට දීලා තියෙන lazy අර right read විදියට දීලා තියෙන්නේ. Transaction එකක් අර මෙහෙම කතන්දරයක් දුන්නේ නැහැ. අපිට මේක ඇදලම දීලා තියෙනවා තවත් lazy වෙන්න. හරියට කියනවා read 1x denotes transaction 1 read x value, write 2x denote transaction 2 write x values. හරි? ඒකලු අපේ convention එක. දැන් අඳින්න බලන්න. ඕගොල්ලෝ අඳින්න බලන්න මේක precedence graph එක. I will give 1 minute. So how many transactions? 1 තියෙනවා, 2 තියෙනවා, 3 තියෙනවා, 4 තියෙනවා, 5 තියෙනවා, 6 තියෙනවා. There are 6 transactions. Right, 6 transactions. You have to draw the precedence graph and see whether there are cycles. Right, do it. වැරද්දුවට කවන්නේ පුළුවන් විදිහට අඳින්න. ඔයාලට හිතෙන විදිහට අඳින්න. එතකොට වැරදිච්ච තැන් ටික අහු වෙනවා. Do it. Anyone? Ada kenek innada? Andin bal. Samar bය වෙලා දැන් මේක පහක් විතර තියෙන හන්දනේ. බය වෙන්නේ මොකද? Right. So this is write 1A, read 2A, right? So second transaction, right? Right. What we can do is we can write it like this. මෙහෙම ලියමු. එතකොට මේක ලේසි. දැන් මෙහෙම දිනකොට පැටලෙලානේ. Say write 1A, okay, write A, say transaction 1, transaction 2, transaction 3, transaction 4. හයක් තියෙනවද? හයක් තියෙනවනේ. තව ඉන්නවා. Say transaction 1, transaction 2, transaction 3, transaction 4, transaction 5, transaction 6. Right, write 1A. Write A. Then 1 කියන්න ඕනේ මම T1 line එක අඳින්නේ. Read 2A. Read A. Write 1B. Write B. 1 කියන්නේ උඩනේ. Read 1F. Read F. Read 6G. On highway ni ekkena read karnawa G. Read G. Write 3C. Write C. Read 2C. Read C. Okay. Read 4B. හතරවෙනි එක්කෙනා read කරනවා B වල. Write 2D. මට ඊටමදි වෙන ප්‍රශ්නයක් තියෙනවා හැබැයි. යා දැන්. අන්තරිය මෙහෙම පටන් ගන්න තියෙනවා නේ. කොහමයි චක බ්ලාස්ට් කරලා අඳින්න. Read B. තඩිය මෙහෙම කරනවා. Read 2. Read 4B. Yeah. Then write 2D. Write D. Read 4F. Read F. Write 4E. Write E. Write 5C. Write 5C. And read 5D. Then read මොකද ඊට මදි වුණානේ. අනිත් එක අඳිනවා. Right. So then read 5D. Read D. Read 2D. Read 2D. Write 5E. Write 5E. Read 6F. Read F එකක් තියෙනවා. Read 6F. Read 1B. මෙයාගේ උනා ඉතුරු එක්කෙනෙක් වෙනවා. Read 1B. And finally write 6G. මෙන්න මෙයා. ඇවිල්ලා write 6G එකක් තියෙනවා. අන්තිම එක්කෙනෙක්. අන්තිම එක්කෙනෙක්. පුළුවන් ඉතින් මාක් කරමු. පේනවද දැන් ස්ක්‍රීන් එක? Right. So this is write and read. Write and read ඔන්න තියෙනවා පළවෙනි එක. So write to read and that is T1 to T2. T1 to T2. Then this is B, no issue. This is F, no issue. F පළවෙනි පාර වුනේ. This is read G. G is the first time we are getting. No issue. This is write C. C we got for the first time, no issue. Now we have write C and read C. That is T3 to T2. T3 to T2. Okay. Write, read, CC. Same data, I can write. Then B, read B and write B. You can see write B and read B. So that is T1 to T4. T1 to T4. So then write D is there. D for the first time C, C, B, G, F. Yes, first time. F. Method read F. Method read F. It's not an issue because both are read. Though they are different transaction, both are read. Read F. Read F. I read F. Yes, no issue. Write E. E first time A, B, F, yes, first time. Write C. Write C. So here we have read C. Here we have write C. And dependency at the end. That is transaction 2 to transaction 5. Transaction 2 to transaction 5. Then D. Write D to read D. That is transaction 2 to transaction 5 again. So we call it mention color. So this is also transaction 2 to transaction 5, transaction 2 to transaction 5. So එකපාරක් mention කරාම ඇති ඒ dependency penalty. What else? So this is also read D. But that is read. No issue, right? Because this is read D, this is also read D. This is same transaction. It was a read D to write E. Write 6C. Write 6C. Read D. Read 2D. Write 5E. Write 5E. Make E. E use කරලා මේතින් write එක. Write. That is transaction 4 and transaction 5. මේක මකුන් දෙයක්. මේ D එකට ප්‍රශ්නයක් උනේ නැහැ නේද? So then that is write D. Then read 6E. Read 6E. E ne. Read 6. Yeah, this we have a issue. 5 and 6. Write and read. 5 and 6 අතර තියෙනවා. හරි. තවත් තියෙනවද? E තව කොහෙද තියෙනව නේද? මෙතනත් තියෙනව නේ. A will T4. So that means T4 and T6 also that's a you can see write and read. That is T4 and T6 also there. තවත් තියෙනවද? බුදුවා. Read D, read 1B. ඊට පස්සේ මෙයා B කොහෙද අහුනේ අපිට? මෙයා අවුලක් නැහැ write B නේ. එයාගෙමනේ. මෙන්න read D. Yeah, but those are two reads. Two reads are not issues. Nothing else, right? එහෙනම් අවුලක් නැහැ. write එක එයාගෙමයි මේ read එක අවුලක් නැහැ read. So then write G. නේද? 6 වෙනි එකන G write කරනවා. G කොහේ හරි හිටියද මේක කලින්? G A, B, F, එයා read 60. එයා අවුලක් නෑ. එයාගෙමයි G වෙන කවුරු හරි use කරාද? නෑ. So that is not an issue because this read and this write is not conflicting because they are same. They are same. Now you have to see whether are they in cycles. T1 to T4. Cycles පේනවද? මෙහෙම ගිහිල්ලා මෙහෙම ගියාට වැඩක් නැහැ. cycle එකක් නැහැ. මෙහෙම ගියාට අවුලක් නැහැ. No cycles. ලොකු complications තියෙනවා මේකද? හැබැයි කොහෙවත් cycle නැහැ. Cycle නැහැ කියන්නේ වැඩි අවුලක් නැහැ. So that means this is serializable. No cycles. Right? No cycles. So that means this is serializable. Right? බලමු serializable කියලා. තේරුම් නැත අහන්න ආයි කරන්න දැන් ක්ලාස් එකේ වුණාට පස්සේ අද රෑ නිදා ගන්න කලින් ආයි මේක අරගෙන අඳින්න ඕන. බලමු. The precedence graph contains no cycles, therefore the schedule is conflict serializable. Right, yeah. Okay. Schedule is conflict serializable. බලන්න මගේ එකත් මේක හරියද කියලා. බලමු මගේ අපේව තියනවාද කියලා. T1 to T2. Ini මෙයා මෙන්න පාටි ගන්න ඉන්නවා. T1 to T2. T1 to T2. I can do bad. T3 to T2. T3 to T2. T1 to T4. T1 to T4 hari. Metulah hari. T4 to T5 hari. T2 to T5 hari. T4 to T6 අන්න ඒක අඳගත් නෑ මෙතන තව එකක් එන්න ඕන T4 to T6 එන්න ඕන ඒක අඳලා නෑ එහෙම එන්න ඕන then T5 to T6 ඒක අඳගත් නෑ මේ දෙක මේ T6 අඳලා තියෙන එකයි ඒ දෙක එන්න ඕන T3 to T5 එකක් අඳලා තියෙන කොහොමද T3 to T5 එකක් නෑනේ T3 to T5 එකක් තියෙනවද කියලා මේක කොහෙද T3 to T5 WC මෙයාද ඔව් තියෙනවානේ මේ WC මෙතන WC තියෙනවනේ WC yes T3 to T5 එකකුත් තියෙනවා නමුත් ඒකෙන් cycle හැදුන්නේ නැහැ ඒකෙන් cycle හැදුන්නේ නැහැ so but there are no cycles here okay, there are no cycles there so therefore that is not issue so එයාගෙත් මොකක් හරි එකක් හරි මොකක් හරි අපිට වැඩි වෙනස් තියෙනවා මම හිතන්නේ එයාගේ වැරදි ඒක ඩබල් චෙක් කරන්න ඩබල් චෙක් කරලා බලන්න මට ආපු එක දෙන්නේ එක්සැමිනේට ආපු එක දෙන්නේ කියලා හරි අපි කරපු විදිහ වැරද්දක් නෑ කරපු විදිහ 100ක් හරි සමහරවිට මෙතන එකක් දෙකක් මට මිස් වුණාද දන්නේ නෑ සමහරවිට මට මිස් වෙලා තියෙනවා නැත්නම් එක්සැමිනේට මිස් වෙන්න පුළුවන් හරි මේවා මිස් වෙන්නේ නැති වෙන කොහොමද කරන්නේ නේද මනහක් විතර දුන්නා hari but anyway no cycles okay බලන්න double check කරන්න ඕගොල්ලෝ right so that is how you do it දැන් පේනවනේ exam එක නිකන් මේ බබා part එකක් නෙමෙයි hari මේ degree level එක right so you have to face the reality right now let's move on then තේරෙනවනේ precedence graph එක හදලා බලන විදිය so if there are no cycles it is conflict serializable okay it is if there are cycles it is not conflict serializable right දැන් පොඩි practical example එකක් කරන්න හදන්න හරි right assume that we have a schedule right? Assume that we have a schedule now these are some transactions Right? So I have one transaction 1, and this is another transaction. Okay. So there are two possible serial schedules. What it does? It add 100 to A and also add 100 to B. That is transaction 1 starts. Transaction 2, multiply A by 2 and write it. දෙගුණ කරලා write කරනවා. ඊළඟට B දෙගුණ කරලා write කරනවා. මෙයා 100ක් එකතු කර කර write කරනවා. මෙයා දෙගුණ කර කර write කරනවා. ඒ දෙන්නම A සහ B එක වැඩ කරනවා. So this is your transaction 1, this is your transaction 2. So there are two serial schedules. Why? Two schedules can factorial 2 කියන 2. T1 after T2 or T1 and T2 or T2 after T2 then T1. So both schedules are valid because they are serial. So this is the first serial schedule. Right? If you do this serial schedule, assume some random value for A and B. ඒගොල්ලෝ ඉතල තියෙන A සහ B 25යි කියලා ගමුලු. එහෙනම් මෙතන 100 එකතු කරාම 125. Here B is 125. මේක 25 වෙන්න ඕනේ නැහැ 25 30යි කියලා ගන්නත් පුළුවන් මට හරි. So then you are multiplying by 2. Now this transaction is done. Now these are the current value of 100 A. 125 into 2 is 250. 125 into 2 is 250. So the final answers are 250 and 250. If it is executed as a serial schedule, T1 and T2. Now look at schedule B. That is another serial schedule, T2 then T1. Again, let's assume same values, 25 and 25. Make 25 වෙන්න ඕනේ 25 30 කියලා ගත්තත් කවන්නේ නැහැ. 5යි 15යි කියලා ගත්තත් කවන්නේ නැහැ. Now first we are multiplying by 2, therefore A is 50, B is 50. Now we are adding 100. 50 plus 100 is 150. 50 plus 100 is 150. Now you can see that two different serial schedules. When you do T1 and then T2, your final balance are 250 and 250. When you do T2 and then T1, your final balance are 150 and 150. You can see that first serial schedule results in one result. Second serial schedule result in a different. If you take the same initial balance, we are getting two different results. So then someone will ask, how can it happen? Then how do you know that both serial schedules are correct? Yes, both serial schedules are correct. Though it's result in two different values, both are business logic wise the same. Sorry, business logic wise valid. මොකද ඉස්සර වෙන එක අපිට කරන්න දෙයක් නැහැ. ඉස්සර වෙන්නේ කවුද කියන එක. නමුත් ඔය දෙකේ ප්‍රශ්නයක් නැහැ. Right? So therefore you don't think that all serial schedules are going to give you the same output. No, we are not interested in the output, but we are interested is it is a valid or not, business rules wise. As long as the business rules wise those are valid, we don't care the final value. We don't care the final value. Right? ඒක කවුරුත් බැංකුවත් එක්කවත් කාත් එක්කවත් තරක කරන්න ඉන්න බෑ. ඒ කියන්නේ හරියට මේ වගේ හරි අපි තියෙන එක පිටි පැකට් එකයි. මොන අන්තිම හයිලන්ඩ් පිටි පැකට් එක ලං නේද? ඇන්කර් පිටි පැකට් එක තියෙන්නේ. ඉතින් මේක x ඉස්සෙල්ලා ආවොත් එමේ x දෙනවා y ට කියනවා නැහැ කියලා. y ඉස්සෙල්ලා ආවොත් එමේ y ට දීලා කියනවා x නැහැ කියලා. ඉතින් එහෙම කිව්වයි කියලා මේ සුපර් මාකට් එකත් එක්ක ගහගන්න බෑනේ x යි y ටයි. එතකොට සුපර් මාකට් එක පැත්තෙන් ඒ දෙකම එකයි. x දීලා y ට නැහැ කිව්වත් එකයි y ට දීලා x නැහැ කිව්වත් එකයි. දෙකම valid. දෙකම valid. ඒ වගේ තමයි යා. So it doesn't matter whether the final balance is 250 250 or 150 150, both are valid. What we care is whether it's a valid or not. As long as it doesn't violate rules, that is fine. Okay. So now you have two schedules, two serial schedules result in two different final outcomes. Both are okay. Now let's try to mix. What that mix karna? So that means this is not a serial schedule. We are doing bit of T1, bit of T2, again come back and do T1, then again come back and do T2. Right. Now Again, we are starting at 25, 25. You are adding 100, 125. Now you are multiplying A by 2, 250. Now you add B, 100, add to the B, 125. You multiply it by 2, 250. So this is your final result. Okay. Now see whether we have cyclic dependencies. Now we have to draw precedence graph and see whether this is serializable. මේ question එක කරන් තේරුම් ගන්න කතන්දරේ machine එකේ හදන්න නැතුව. Now this is දැන් උන ආය හඳිමුවා read write read write read write read write හරි පේනවනේ read write read write read write read write. Do you have any dependencies? This is same. This is write and read dependency T1 to T2. What else? This is also A to A, but right to right. Already we have shown T1 to T2. What about this? B, first time we are working with B, no issue here, same transaction. Write B, read B, or write B, write B. So that is again T1 to T2. Already we have mentioned that. Right? T1 to T2. So can you see a cycle? No cycles. No cycles. So therefore, this is conflict equivalent, right? So this is conflict serializable schedule. So this schedule is valid, business rules wise valid, and if you closely look at it, this is equivalent to serial schedule T1 and T2. T1, T2 after T1. But T2 after T1 කරපු එකයි 250 දෙක. මේක T2 and T1 අනිත් එක. මේ T1 පස්සේ ඔයාලා 250. So මෙයාගේ result එක. This is not a serial schedule, but the result is equivalent to this serial schedule. Make a karam which is result එක මේකෙනුත් එනවා. කලවම් කරලා කරාට. So ඒක ඔයාලට පේනවා මේක මේ ඊතල ගියාට පස්සේ මේක යන්නේ කොහමද? T1 T2. ඒ කියන්නේ මේක equivalent වෙනවා T1 T2 කියන serial schedule එකට. T1 T2 කියන serial schedule එකට equivalent එක. So therefore, this is conflict serializable schedule because no cycle, and it is equivalent to T1 followed by T2. So let's look at another schedule. This one. So you do the first part of the transaction 1, then we do the full transaction 2, then we do the second part of the transaction 1. එහෙම කරන්න පුළුවන් නේ. අද අපි බලමු ඉස්සෙල්ලා precedence graph. So this is read write, but same transaction. This is read, this is write. So that is T1 to T2. Right, read is not issue, but then write to read is there. Write to write is also there, but anyway we have mentioned T1 to T2. Now we are working with B for the first time, no conflict. Now write B, read B. And also write B, write B. So that is T2 to T1. Cycles. On the cycle. So therefore, this transaction is not conflict equivalent to any of the serial schedules. So this is not going to work. This is not going to work. Again, let's start with 25, 25. 125 to 100, 125. 125 දෙකෙන් වැඩි කරාම 250. Now we are multiplying b by 2, 50. Now we are adding 100. 50 plus 100, 150. ඔන්න අපිට ආවා a ට 250 ආවා b ට 150 ආවා. මෙහෙම උත්තරයක් ආවද එක serial schedule එකවත් 250 150 කියලා. So this is one serial schedule 150 150 250 250. No, we didn't get it. එන මෙයා අර වගේ එකට ඉක්විවලන්ට් එකක් වෙලා නම් අඩු ගන්න උත්තර සමාන වෙන්නේ උත්තර සමාන නැහැ කියන අනිවාර්යයෙන් මෙයා. So this is having cycle. So therefore this schedule is not conflict serializable to any of the serial schedules. So this is not valid. Make කරන්න එපා. So this is not going to work because we have cycles. Okay, T1 to T2, T2 to T1. Okay, T1 to T2, T2 to T1. Right. So the next thing is how to find the equivalent serial schedule. සමහර ඒවා නම් ලේසි. උදාහරණයක් ගන්න මේ වගේ එකක් ගත්තට පස්සේ මේක ඕන් ඉක්වලන්ට් නැහැනේ. ඔයාලට ඒකෙදිම පේනවා මේ T1 ගෙන් පටන් අරගෙන T2 ට කියලා ඉවරුණා. හැබැයි සමහර ඒවාට එහෙම පේන්නේ නැහැ. උදාහරණයක් අර මම කරු මේක පේන්නේ නැහැ එනවා. ඔව්. මේකේ එහෙම පේනවද කොයි මොන සීරියල් ෂෙඩියුල් එකටද ඉක්වලන්ට් කියලා කියන්න පුළුවන්ද? මේකේ අවුලක් නැහැනේ. සයිකල් නැහැ. දැන් ඔයා කියනවනේ මේක මොන සීරියල් ෂෙඩියුල් එකටද ඉක්වලන්ට් කියලා අහනවා. බලන්න අහලාදී යටින්. then determine an equivalent serial schedule. මෙයා මොන serial schedule එකටද අහනවා equivalent වෙන්නේ. cycle නැත්තම්. examiner ලියලා ඇති ඔබේ. මොකටද කියලා. T1, T3, T2, T4, T5, T6. කොහොමද මේක ගන්නෙ? T1, T3, T2, T4, T5, T6 කියලා කොහොමද යාරන්නේ? ඒක හොයන විදිය තමයි දැන් කතා කරන්නේ. Right, so this is how you do it. How you find? Start with one node. එක node එකකින් පටන් ගන්න. Check if there is a path that travels all the nodes. ඒක දිගටම ඔක්කොම nodes වලට යන පාරක් තියෙනවද කියලා හොයාගන්න. එහෙම තියුණොත් අවුලක් නැහැ. That path represents the equivalent serial schedule. ඒක තමයි මෙතන උනේ. So you start T1 and you go to the T2, all are covered. So therefore our serial equivalent serial schedule is T1 followed by T2. But that is not always going to happen when we have so many transactions. So then we need a more systematic approach. So this is what we have to do. Start with any node having in degree of 0. අපි මේකට in degree of 0. in degree එක කියන්නේ යාට කවුරුත් in වෙන්නේ නැති වෙන්න ඕන. එහෙම නැහැ. උදාහරණයකට මෙතන ගත්තොත් එහෙම මෙන්න මෙයාගේ in degree එක 0. කවුරුත් in වෙන්නේ නැහැනේ. මෙයාගේ in degree එක 0. in වෙන්නේ නැහැනේ. අන්න එහෙම අයගෙන් තමයි පටන් ගන්න ඕන. හරි. එහෙම අයගෙන් පටන් ගන්න ඕන. පේනවද මෙයාගේ උත්තරේ T1 හරි T3 වලින් හරි තමයි පටන් ගන්න තියෙන්නේ. T1 in degree 0. මෙයාගේ in degree 0 නෑ. මේ in එකක් තියෙන්නේ. So T2 in degree is not 0. In degree is 2. Here in degree is 1. Here in degree is 3. 1, 2, 3. Here in degree is 2. So you have to start with either T1 or T3 in this case. Okay. So start with in degree 0. I know incoming arrows. Mark the node and remove all the outgoing arrows from that mark node. ඒ node එක mark කරලා ඉවරලා එයාගෙන් එළියට යන ඒවා ටික අයින් කරලා දාන්න. දැන් උදාහරණයක් අපි mark කරොත් එimhe T1 කියලා. T1 කියලා. දැන් මේ දෙන්නව අයින් කරලා දාන්න. Now pick another node having the in degree 0. ඊට පස්සේ තව එකක් ගන්නවලු in degree 0 වෙන. අපිට ගන්න පුළුවන් ඕනනම් දැන් මොනවාද? T4 ගන්න පුළුවන්. අයි මේ දෙන්නම දැන් අයින් කරන්නේ. T2 ගන්න බෑ මෙහෙන් යනවානේ. ඕනනම් T4 ගන්න පුළුවන් නැත්නම් T3 ගන්න. අපි T3 ගමු. දැන් T3 ගත්තම යාගේ out යන ඒවා ටික අයින් කරන්න. Repeat this until all the nodes are covered. That path represents the equivalent serial schedule. දැන් ඔන්න T3 ගත්තම මේ දෙන්න අයින් කරා. දැන් මට multiple possibilities තියෙනවා. දැන් මට ඕනනම් පුළුවන් T2 කියන්න නැත්නම් T4 කියන්න. I will take T2. මෙයා අයින් වෙනවා. තාම T5 කියන්න බෑ in degree තියෙනවා. but T4 no not nothing. T4. එතකොට මම මෙයාව අයින් කරන්න ඕනේ මෙයා අයින් කරන්න. දැන් T6 බෑ තාම in degree එක තියෙනවා. දැන් T5. එතකොට මෙයා අයින් වෙනවා. දැන් T6 එක කවුරුත් නැහැ T6. ඔන්න ඔක දැන් මට ආපු equivalent serial schedule එක නා. හරි. ඔතන පොඩ්ඩක් එහාට මෙහාට වෙන්න පුළුවන්. ඕනනම් T1 T3 නැතුව T3 T1 කියලා ගන්නත් පුළුවන්. හරි. බලන්න මේක වලට ඇවිල්ලා තියෙන පස්සේ අපේ පොඩි කම්ප්ලීට් එකක් තියෙනවා ප්‍රොසීඩර් graph එක නා. T1 T3 T2 T4 T5 T6 හරි ඒක හොඳයි ඇවිල්ලා තියෙනවා. graph එකේ පුටපට දිනන මොකද දෙන්නගේ උත්තර දෙකම සමානයි. යා. T1 T3 T2 T4 T5 T6 හරි. මාක් කරපුව ගමන් එයාගෙන් එළියට යන විදිහ මකන්න ඕන. in degree 0 අය තමයි ගන්න ඕන. Okay. අපි තව පොඩි example එකක් කරලා ඉමුද? මේ database කතන්දරේ සෑහෙන ඉවර කරන නිදහස් දවසේ ආ. එදාට උදේ ක්ලාස් එකක් දානවා. මට එදා හවසට ගන්න පුළුවන් වුණා. ඕනනම් දෙක විතරට ගන්න. database ඉවරම කරලා දාන්න පුළුවන් ඉවරම කරලා දානවා. ඒ වගේ තව එක්ස්ට්‍රා ක්ලාස් එකක් දෙයක් දාන්න වෙයි ආ. පෙබරවාරි වලට තියෙනවා කියලා නිවාඩු දවසුත්. මේ ගණන් ටික හදන්නත් තියෙනවා හරි. මම එක් කරන්ට අග do it. දැන් මේක වැඩි ගොඩක් නෑ. කරන්න පුළුවන් වෙන්න ඕන. Consider the following schedule created using 5 transactions. Is this schedule conflict serializable? Give reasons. හරි. මට කරන්න. equivalent serial schedule එකක් ලියන්න ඕන. අහලා නෑ මේකේ. හැබැයි conflict serializable නම් අනිවාර්ය equivalent serial schedule එකක් ඔයා ලියන්න ඕන දැන්. Let's throw it here. How many transactions? 1, 2, 3, 4. 4 ne? Transaction 1, transaction 2, transaction 3, transaction 4. Read 2x, read x, read 1y, read y, read 1z, read z, read 5v. Oh, 5v would be. Read v. Read 5w. Read w. Write 5w. Write w. Read 2y. Read y. Write 2y. Write y. Write 3z. Write z. Read 1v. Read b. Read 4y. Read 4y. Write 4y. Write y. Read 4z. Write 4z. Read 1u. Read u. Write 1u. Write u. Then precedence graph करने पर x y අවුලක් නැහැ z v w w same no issue on the y read no issue read ne and read write t1 to t2 right. Then this is z read dz write dz T1 to T3. This is V. This is also read, but read, no issue. Read. Y, read Y. This is read Y. This is write Y. Write Y, read Y. That is T2 to T4. Then we have write Y, read Y, write Y. T1 to T4. T1 to T4. තවත් තියෙනවද? මේක ඕල්ඩි ගත්තනේ. Z, read DZ දවුලක් නෑ. Write DZ, read DZ. T3 to T4. Right. Then write DZ is again there. ඒක දැන්ට වරන් තියෙන්නේ. Read DZ. Here we have read DZ to write DZ. T1 to T4. ඒක already අරන් තියෙන්නේ. මෙන් ආවනේ. තව උනක් තියෙනවා. U. First time U ආන්නේ. First time ne U. No issue. Read U, write U. U is not used anywhere. So therefore no issue. දැන් බලන්න cycle තියෙනවද? cycle නැහැ නේද? Cycle නැත. No cycles. Right? Going get cycle. So therefore this is valid. This is valid. The precedence graph contains no cycles, therefore the schedule is a conflict serializable. Right? Precedence graph එක තමයි වැඳලා. බලමු මේක හරියද කියලා. අපේ එකත් එක්ක. T1 to T4. T1 to T4 මෙයා හරි. T1, T2, T4. T1 ගෙන් T2 ට ගිහිල්ලා T4 ට එනවා. හරි. T1, T3, T4. T1 ගෙන් T3 ට ගිහිල්ලා T4 ට යනවා. T1 ගෙන් T3 ට ගිහිල්ලා T3 හරිනේ. Right. Correct. Now let's see which මේක කාටද equivalent කියලා බලන්න ඕනේ දැන්. අහලා නැහැ ඒගොල්ලෝ. හරි. අපි හොයමු. මොකද කරන්නේ? නිකන් ඇහැට පේන්නේ නැහැ ඔක්කොම කව වෙන එකක්. එහෙනම් දැන් in degree 0. In degree 0 is T1. So you have to write T1. Now you can delete this and this. මේ දෙක දැන් තුනම අයින් කරා. ගත්තම යාගෙන් outgoing එක මකනවා. දැන් ආයේ in degree 0 එකක් ගන්න ඕන. You can either write T2 or T3, it doesn't matter. But T1 ට පස්සේ T2 ගත්තත් කමක් නැහැ, T3 ගත්තත් කමක් නැහැ. T2 ගත්තා. එතකොට මෙයා මකන්න ඕන. දැන් ඉතුරු වෙන්නේ T3. එතකොට මෙයා මැකෙනවා. දැන් මෙයාගේ in degree බිඳුවයි. මේක එක උත්තරයක්. එහෙම නැත්නම් T1 T3 T2 කොහොම ගත්තත් හරි. T1 T3 T2 T4 both are මෙයාටත් equivalent මෙයාටත් equivalent. මේ දීපු schedule එක. So therefore this schedule is equivalent to either this serial schedule or this serial schedule. Because these two serial schedules are again equal. Okay. So therefore yes. Any questions? මෙයා මෙතන අහලා නැහැ serial schedule එක. ඒක හන්දේ ඇලියලා නැහැ. ඕන serial schedule එකක් කිව්වා. හරි. So full marks you can take without any issue. Okay. Right. So now we are moving to the second part. BIT-UCSC check current form. That is check whether what we did is using the precedence graph, you can check whether it is conflict serializable. If so, to which serial schedule it is conflict serializable. So this is checking whether it is BIT-UCSC. BIT-UCSC. So I told you that. So we have the serial schedules. Right. So we have the serial schedules. They are all good. Then we have conflict serializable schedules. That is also good. But not all conflict serializable schedules are serializable. So there are some serializable schedules, though they are not conflict serializable, still they are serializable. Still they are equivalent to a serial schedule. So those are called conflict serializable schedules. Precedence graph එකේ cycle ආපු බලියට අපිට කියන්න බෑ ඒක serializable නැහැ කියලා. අපිට කියන්න බෑ ඒක complete serializable නැහැ කියලා. හැබැයි ඒක තාම view serializable වෙන්න ඉඩ තියෙනවා. Right? So therefore now we want to see whether how to check whether a particular schedule is view serializable. view serializable not ඒත් serializable. view serializable නැත්නම් එහෙනම් ඒක අනිවාර්යෙන් non serializable. Right, how to check whether a given schedule is view serializable? Right. It's very easy. You have to check 3 conditions. Right, you have to check 3 conditions. So that is, we say that schedule 1 and schedule 2 are view equivalent if the following 3 conditions hold, or if the following 3 conditions satisfy. Condition 1, initial reads are preserved. Write read conflicts are preserved. Final writes are preserved. If these 3 conditions satisfy, those 2 schedules are view equivalent. And if one is serializable, the other one is also serializable. Because, okay. So if schedule 2 is conflict serializable to a serial schedule, but schedule 1 is not conflict serializable to a serial schedule, but this one is conflict serializable to the serial schedule, but this one is not conflict serializable. But if S1 is view equivalent to S2, now S1 is also serializable. Though it is not conflict serializable, it is view equivalent to a conflict serializable schedule, and therefore we can say S1 is also serializable. That is how you do it. Initially you don't get it, because this is not conflict serializable to this one, but this is view serializable to this one. And this is conflict serializable to this one, therefore this is also serializable. Okay. Right. So what are these 3 conditions? Initial reads, write read conflict, and final writes. Now we have 2 schedules. Making තාම ප්‍රශ්න අහලම නැහැ view serializability වලින්. ඒකන්ද ඒක තේරෙනවා නම් තේරුම් ගන්න. ප්‍රශ්නයක් වදින්න තේරෙනවා නම් මේක තේරුම් ගන්න පුළුවන් දෙයක් නේ. Right. So we have 2 schedules. Schedule 1 and schedule 2. Now we are going to check whether these 2 schedules are view equivalent. Okay, view equivalent. So first condition is, in both the schedules, the initial reads must be done by the same transactions. Initial reads කරලා තියෙනවනේ එකම transaction වලින් දෙකේම. බලමු. So we have 2 variables x and y. Sorry, we have only x. X විතරයි තියෙන්නේ. එහෙනම් initially x read කරේ කවුද පළවෙනි trans schedule එකේ? එයාම තමයි read කරලා තියෙන්න ඕන දෙවෙනි schedule එකේ. එතකොට අපි කියන පළවෙනි condition එක satisfy කියලා. So which transaction has read the x in this schedule 1? T3 and T2. කාටද කියන්න පුළුවන් එහෙම T3 and T2 නේ කොහොමද කියලා. දෙන්නම උනේ කියලා. ඔව් දෙන්නම උනේ obviously T3 read x first and T2 also read before write to anything. එයාට write කරන්න ඉස්සෙල්ලා. ඒ කියන්නේ අපි කියන්නේ සාමාන්‍යයෙන් මොකද ඔයගොල්ලෝ සාමාන්‍ය භාෂාව කියනවනම් කියන්නේ මොකද්ද? නෑබුල් නේද? නොයිදුල්. නොයිදුල් වෙලාවේ රීඩ් කරලා තියෙනවා. රයිට් කරන්න කලින්. ඔව්. රයිට් කරන්න කලින් මේ දෙන්න තමයි රීඩ් කරේ. T2 සහ T3. So මේකෙත් බලමු කවුද රීඩ් කරලා තියෙන්නේ කියලා. T2 reads and T3 reads. අන්න පළවෙනි condition එක satis. So initial reads are done by T2 and T3 in schedule 1, and here also initial reads are done by T2 and T3. So therefore first condition is satis. අපි ඊට අන්තිම condition එක බලමු. let's make it. Final writes are preserved. මේකේ කවුද අන්ත අවසාන වතාවට write කරේ variable වලට. Now you can clearly see that the final write is done by transaction 1. අන්තිමට extra write කරලා තියෙන transaction 1. මෙතන කවුද write කරලා තියෙන්නේ? Transaction 1. So final writes are also done by the same transaction. So therefore that is also satis. මෙතන final write එක මේ T1 ගහලා මෙතන final write එක T2 ගහුවා නම් එහෙම ඔන්න view එක කරන්නේ නැහැ. So then write read conflicts are preserved. Write read තියෙනවා preserve වෙන්න ඕන. So this is read read. This is read write. This is a write read. ඔන්න write read එකක් තියෙනවා. කොහොමද write read එක කියන්නේ T3 to T1. මෙතන මොකද තියෙන්නේ? read write ඔන්න write read එකක් තියෙනවා. T3 to T1. ඒකත් හරි. So this is write. මේක read write. එකම transaction එක ඕන ප්‍රශ්නයක් නැහැ. Write read බලන්න ඕන යා. Write read T3 to T1, write read T3 to T1. එන එතනත් අවුලන්නේ. So all three are satisfied. So therefore this is v equal to this, or we can say this is v equal to this. මේ දෙක එකක් හරි serializable නම් අනිත් එක නම් serializable. මොකද මෙයා serializable නම් මෙයාට v equivalent නම් දැන් මෙයා serializable වෙනවා. මෙයා serializable නම් මෙයාට equivalent නම් මෙයා serializable වෙනවා. හරි. අන්න එහෙමයි view equivalent කියලා බලන්න. එතකොට ඒ බලන එක්කෙනා serializable නම් අනිත් එක්කෙනාත් automatically serializable වෙනවා. එයා conflict serializable නැතත් එයා conflict serializable එක්කෙනාට view equivalent නම් එයාත් දැන් serializable වෙනවා. හරි. Okay, so done. ඔරුතු දෙනක් දන්නේ මෙච්චර ගොඩක් දවස් කරාම මැරෙයිද දන්නේ නැහැ නේද? Right, another concept called recoverability. Okay, so recoverability. What is mean by unrecoverable schedule? Okay, unrecoverable schedule. So there are two types of schedules: recoverable schedules, unrecoverable schedules, and some recoverable schedules needing cascade rollbacks. Okay, right. Now let's first look at what is mean by recoverable schedule. Now what will happen? Now let's see what are the possibilities here. So there's a write operation from transaction 1. From transaction 2, there's a read operation. That write value is now we have read it. Now we are doing something else with B, that is different tasks. Now you have commit. Now, unfortunately, this guy has abort. This guy has abort. Now it's too late. This guy has committed. So therefore, this is unrecoverable schedule. Make a recover karane base tatya. I will tell you a very simple example. Okay. Say there are two students, X and Y. Okay. Y needs some money. Y ට ගෙදර යන්න මොනාරි සල්ලි නැති වෙලා මොකක් හරි වෙලා. මං ගාවත් සල්ලි නැහැ. මම X කෙන් සල්ලි ටිකක් ඉල්ල ගන්නවා. X කෙන් කියනවා හරි වාට පුළුවන් මෙයාට රුපියල් 100ක් දෙන්න. හරි X කියනවා හා පුළුවන්. හරි. මම මේ 100 මෙයා 100 මෙයාට දෙනවා. දුන්නට පස්සේ මිනිහා රුපියල් 100ක් යනවා කමිට්. දැන් 100ක් මෙයාට දුන්නා. එයා ඒ 100 අරගෙන කමිට් එයා ගියා. දැන් මෙන්න x කියනවා මාර සීන් එක අර මම දුන්න 100 මට ඕන කියලා. AC විතරයි මගේ අතේ දුන්න දැන් මට ගෙදර යන්න විදියක් නැහැ. මම හිතුවා මගේ අතේ තව සල්ලි තියෙනවා කියලා. දැන් මට 100 ඕන. දැන් මේක රිකවර් කරන්න පුළුවන්ද? ඉතින් මේක ගෙදර ගියන්නේ 100ක් අරගෙන. දැන් මෙයා ඇබෝට් වුණාට දැන් මේක විසඳන්න බැරි ප්‍රශ්නයක්. දැන් මෙයා මගෙන් මට කියනවා අනේ මට ආයෙ 100 ඕන. 100 ඕන කිව්වට මම මොනා කරන්නේ? මෙයා දුන්න 100 මෙයාට දුන්න මිනිහා අරන් ගියේ කමිට් කරලා. දැන් ඉන්නේ කරන්න දෙයක් නැහැ. දැන් කරන්න දෙයක්. So this is unrecoverable schedule, unrecoverable situation, right? But if this is not aborted, this is perfectly okay. But who knows? There is that possibility might be there. Possibility of abortion is also there, right? So therefore, this is not a good thing to do. This is very risky thing to do. If you have this kind of a schedule, it is very risky schedule because there's always possibility of getting into a trouble because we never know that this possibility of abort is there and you can't recover this. Okay, so this kind of schedules are called unrecoverable schedule. Okay, so recoverable schedules are two types. So this is anyway unrecoverable, right? Recoverable schedules are two types. Some schedules, they are strict schedules. So they are always recoverable without any issue. Then some schedules are cascade. So some schedules are always recoverable. We call them cascadeless. When a card roll back කරන්න දෙයක් නැහැ කොහොමද recover වෙනවා. But there are some schedules which are recoverable but only after doing some cascade rollbacks. Cascade rollback කරාට පස්සේ තමයි recover වෙන්නේ. Some schedules are not recoverable, some schedules are recoverable but we need to do cascade rollbacks, right? Some schedules are recoverable in general way. Okay, මොකද මේ cascade rollback කියන්නේ එක්කෙනෙක්ව roll back කරාම අනිත් අය එක්කනවත් roll back කරන්න වෙනවා. හරි? roll back කරාට පස්සේ තමයි වැඩේ ගොඩ යන්නේ. For example, if this is done something like this, write a transaction 1, transaction 2, read day, say read day, then write B, then roll back, then commit. Now this is recoverable because this commit is after rollback. If this rollback, what we have to do? When this is rollback, we have to roll back this one also because when this is rollback, this read day is wrong because this is A that is written by this guy. So therefore this red value is wrong. Therefore whenever this is rolled back, this must also be rolled back rather than committing. But recoverable because this is not yet committed. Commit කරලා නැති හන්ද අපිට ඕන්ලා roll back කරන්න පුළුවන්. ඒවට අපි කියනවා මොකද්ද? Recoverable with cascade rollbacks. Cascade rollback එකක් කළා මෙයා roll back කරද්දි මෙයාත් roll back කරනවා. Cascade කියන්නේ රැල්ලට වගේ යනවා ඊළඟ එක්කනට ඊළඟ එක්කන පැතිරෙනවා. මෙයා roll back කරද්දි මෙයාත් roll back කරලා වැඩේ කොට දාගන්න පුළුවන්. Some transaction schedules without cascade rollback. So those are cascadeless recoverable schedules. Some schedules anyway you have already committed, so you have no way to recover that. Right. Then අපි කරේ ඔය lazy වැඩේ. මොකද lazy වැඩේ? When you are given a schedule, check whether it is serializable or not. Conflict serializable or serial? Is it serial? Is it conflict serializable or is it view serializable? That is the easier one. The difficult one is, right? So this is the schedule is already given. schedule එක දුන්නට පස්සේ මේ මෙච්චර කරේ නේද? schedule එක දීලා තියෙන්නේ දැන්. මේ දුන්න schedule එක check කරන්න විතර අපිට තිබුණා. So the real challenge is how to make serializable schedules. So that is the real challenge. Okay. So dynamically creating a serializable schedule. Dynamically. ඔයාලට මේ එන task එනකොට දැන් transaction එනකන් ඔයාලට ඉන්න බෑ. මේ තියෙන task කලවම් කර ඔයා schedule එකක් හදනවා සහ schedule එක execute කරනවා. මේ හරිය හදනකොට මේ හරිය execute කරලා තියෙනවා. So dynamically in real time how to make those schedules. So there are two mechanisms. Right? Then maybe katandare tika. I am not saying that this is something you can't understand. No, perfectly you can understand, but ඒව නිකන් ඔහේ තේරෙන්නේ නැහැ. effort එකක් දැම්මට පස්සේ තේරෙන්නේ. Yeah. Right. So there are two mechanisms to create schedules, serializable schedules. Create, not just verify. Create or make serializable schedules. Databases use these two mechanisms. One is log-based mechanism. Second one is timestamp-based mechanism. So you don't have to use both, but every database system use either log-based system or timestamp-based system. So then there are some other approaches as well, multi-version, optimistic, etc. But we are more interested about these two. Okay. Right. In log-based transaction handling means we are making sure that your transaction is serializable, and we make it and execute it real time. හදන අතරතුර අපි execute කරගෙනත් යනවා. BIT-UCSC. Right. So when it comes to log-based transaction handling, so there are two types of logs. Right. Shared logs and exclusive logs. Okay. Logs වර්ග දෙකක් තියෙනවා. Exclusive logs. Other type is shared logs. Exclusive log means that log is exclusive. Only one transaction can keep that log. No two transactions can keep that single log. Shared log means multiple transactions can keep that log. But without the log, you can't access it. But multiple transactions can keep it at a time. Okay. So logging also can be done at different levels. The best one is you log only the relevant record. Concurrency handle කරන record එක විතරක් log කරන එක තමයි හොඳම විදිය. මොකද so then other transactions have freedom to work with other records. So the second level is log per table. ඔයාට record එක log කරන්න බෑ, record table එකම log කරගන්න වෙනවා. ඒ record එක change කරන්න ඕන නම් table එකම log කරනවා. log කරනවා කියන්නේ අනිත් අයට access කරන්න දෙන්නේ නැහැ. So third one is when you want to do a change to a particular record, you lock entire database. ඒ database එකේ වෙන කිසි කෙනෙකුට වැඩ කරන්න දෙන්නේ නැහැ. ඔයාගේ වැඩේ ඉවරනකම්. මේක ඇත්තට practical use කරන්නේ නැහැ. හැබැයි මේක සමහර ප්‍රාථමික database වල ඔක use කරනවා. හැබැයි හොඳම විදිය, efficient විදිය තමයි you just log the record, because otherwise you are unnecessarily prevent other transaction to proceed until you release your log. I already explained you the two type of logs. The exclusive log, that means only one transaction can take that log and other transactions cannot access it now. Shared log means that resource can be used log by multiple transactions. So then it's a shared log. this is exclusive lock. Exclusive lock එක කතා කරනකම් අනිත් එක්කන බලන් ඉන්නවා. transaction 1 එක exclusive lock එකක් අල්ලන්නම් ඉන්න data එක record එක. එයා lock එක unlock කරනකම් අනිත් එක්කනට lock එක හම්බ වෙන්නේ නැහැ. මේක එහෙම නැහැ. මෙයාගේ lock කරගෙන ඉන්න එක transaction එකක්. අනිත් transaction එකත් ඒවා lock කරනවා එයා. shared lock එක. මේක හරියට washroom එකක ඉන්නවා. හරි. ඒ washroom එකට අනිත් යටත් එන්න දෙනවා. අපි තුමා washroom එකට ඔළුව පීරනවා නැත්තම් වෙන වැඩක් දත් මැද වැදිට එක විතර අවුලක් නැහැ නේ. තව කෙනෙක් ඉන්නවනේ යාට තනවත් ඇතුළට ඇවිල්ලා දත් මැදි. So that's a shared lock. The read operations are shared locks. Read operations වලට අපි දෙන්නේ shared lock ගොඩක් කරලා. But write operations are exclusive locks. Exclusive locks. එතකොට ආ විතරයි washroom එක ඇතුලේ ඉන්නේ. අනිත් අයට එන්න දෙන්නේ නැහැ. හරි. lock කරනවා. දත් මදිනවා වගේ වැඩක් නෙමෙයි දැන් කරන්නේ. That is exclusive lock. This is shared lock. Okay. So some databases use only exclusive locks. So that is not a good idea. So that means if you want to write operation, you have to take exclusive lock. And that write කරන්න බෑ. When you are doing read operation also, you have to take exclusive lock. ඒ කියන්නේ read කරලා ඉවරනකම් අනිත් අයට ඒක record එකත් උත්තරන්න දෙන්න. That is not a very efficient approach. More practical approach is we use write lock as exclusive lock and read lock as a shared lock. ඔක තමයි ගොඩක් practically කරන්න database එක. හරි write operation එක exclusive lock එකක් තියෙනෝනේ කරන්න. read operation එක කරනවා shared lock එක හමුණා මැති. Right. Again, the possible conflict is everywhere other than read. The read එකේදී lock පාට ඕනේ. අරයා treat කරනවා මෙයා treat කරනවා නම් ඔයාට lock එකක් නැතුව 10 දින නෙවෙයි ඔක්කොම ලවුන treat කරාට කමක් නැහැ. හැබැයි අනිත් හැම අවස්ථාවකම lock ඕන වෙනවා. write operation එක lock ඕන. right මේකදී අධික කතාවක්. අපි ඊළඟ දවසේ මේ කතන්දරේ කතා කරලා ඉවර කරනවා.